Hello everyone, my name is Nikitan Dobaria and here we are discussing basic electrical engineering and in which we are discussing for chapter number 4 and that's electrical machines. And in our last video we had started the three-phase induction motor in which we are discussing construction of three-phase induction motor. And in our today's video we are going to discuss how three-phase induction motor works. But before that, before we discuss the how three-phase induction motor works, let's discuss when we provide supply to stator of three-phase induction motor. And as this is the three-phase induction motor, we are going to provide the three-phase supply to stator of the three-phase induction motor. And as this is the three-phase motor, there will be three windings on the stator of this motor. And here in this diagram you can observe over here this is a schematical diagram of the stator of the three-phase induction motor, and when we will wound the three windings of individual phases on stator body, so that winding will cover the three individual portion of this stator body, and this three winding will be at a 120-degree angle with reference to each other. So here you can observe over here. Here we are having three winding at 120-degree with reference to each other. And when we will provide to supply two individual windings, so that individual winding will produces individual fluxes. Basically here we are having three windings, and when this three winding will be supplied, so that will produce three fluxes. And again, as these three windings are at 120-degree angle with reference to each other, that's why these three fluxes will be at 120-degree angle with reference to each other. So these three vectors here R, Y and B are representing the three component flux which is produced by three individual phases. And as we will provide the three-phase supply to these three windings, so according to that, what flux will be generated, having equations are as given in this equation. So when we will provide supply to these three windings, so when this three fluxes will be generated, that can be defined by this given three equations over here. So here we are having equations of phi r, phi y and phi b, where we can consider that if they are in balance condition, so they are going to have same magnitude. Means here we are having all having magnitude phi m and phi n, and these three compounds are at 120-degree compared to each other. As we know that in balance condition, when we provide supply, so angle between voltage, current, or maybe this flux is going to be same, means 120-degree with reference to each other. So basically now if we clear our picture over here, so what are having up to now over here, so we are having three windings, and because of that we are getting the three fluxes in a one stator or in one motor. So basically here we need to find out what will be the resultant flux. So basically here we are going to find out what will be the resultant of this three given fluxes. And for that let's consider case 1 over here. That means when supply will be at zero time or zero angle. So when we will consider the angle is equal to 0, means omega t is equal to 0. So what will be the value of phi r, phi y and phi b, as well as what will be the direction of phi r, phi y and phi b. So we will find out the value of phi r, phi y and phi b at angle 0, and based on this components we will find out the resultant component. So let's consider this case 1 where we are considering angle is equal to 0, means omega t is equal to 0. So if we put omega t is equal to 0 in our previous three equations, so first equation was phi m sine omega t. So where sine omega t is equal to 0 means sine 0. So we are getting the phi r is equal to 0. So this first component, this r component, was in this direction, and as we are getting its value is equal to 0, so the value of this component is going to be 0. That's why this component is shown in some dark color. Same way, if we consider second value phi y, and that was phi m sine omega t minus 120 degree. Now, as if we put the omega t is equal to 0, so we will get the compound sine minus 120 degree. And if we find out the value of sine minus 120 degree, so that is going to be minus root 3 by 2. So basically here we are getting the minus value, and there was a compound in multiplication phi m. So we are getting the phi y is equal to minus root 3 by 2. So here we are getting phi y is equal to minus root 3 by 2. So actually the reference direction of phi y was in this direction, phi y was in this direction. But as we are getting the minus, so that's why we will plot this compound in opposite direction with compared to our reference, and as well as this much length is representing the total phi m. So this length is representing the phi m. So that's why, and this compound are having length or magnitude having minus root 3 by 2. So how much length will be considered? That will be considered according to this ratio. If this length is representing phi m, so this length is representing this magnitude root 3 by 2 phi m in minus direction. Same way, if you consider third compound phi b, so that was phi m sine omega t minus 240 degree, where omega t is equal to 0. So at that time we are getting sine minus 240 degree. And if you find out the value of sine minus 240 degree, we get the plus root 3 by 2. And if you put this value, so we are getting the phi b is equal to root 3 by 2 into phi m. Now phi b was in this direction. So as phi b was in this direction, but as a reference we had considered its magnitude as phi m. But here we are getting the value or magnitude of this component as a root 3 by 2. So based on that, if we consider its particular length, so this blue color vector is representing the this root 3 by 2 phi m means this phi b compounds. And now if we add phi r, phi y and phi b, so first of all, this phi r compound are having value is equal to 0. So basically we are getting this value of this compound is equal to 0. So second and third compound, and that is minus root 3 by 2 over here, and we are getting root 3 by 2 into phi m over here. So by forming a parallelogram over here, if you add this two compounds over here, and again if you want to add this two compounds, you can draw a parallelogram over here, and by that you can find out the resultant compound over here. And again, if you measure the angle over here in between these two, and for that we know that when three references was over here, for reference for R phase, Y phase and B phase over here, so they are having two angle difference of 120 degree. So this angle was 120. Same way, this angle was 120 degree, and this blue to this R phase was again angle 120 degree. Now when this compound is we are drawing this compound in opposite direction, so that is forming 60 degree. So that means if this is 60 degree, this another angle is going to be in 60 degree. So basically now we are having 60 degree, and if you want to find out the resultant of these two compounds having same value root 3 by 2 phi m into root 3 by 2 phi m, and angle is 60. So for that you can use the equation, and that was derived when we had discussed the star and delta connection for three-phase circuit. At that time, we had discussed this type of structure over here, this type of phasor diagram over here, when we are having two compounds, both are having same value and a particular angle in between that. So based on that, we can find out the resultant, and based on that method, we are getting the value of resultant is 1.5 into phi m. So basically, we are getting the magnitude of this resultant is 1.5 times of this individual maximum phi m, and it is in this direction, means in negative y direction. Now, in case number 2, if we consider omega t is equal to 30, and if you put omega t is equal to 30 on in three equation of phi r, phi y and phi b, we are getting the value of phi r is equal to over here, that is 0.5 phi m, value of phi y that is over here, sorry, value of phi y is going to be 0, and value of phi b, when we put omega t is equal to 0, so we are getting again 1.5, sorry, 1 by 5. sorry 1 by 2 into 5. That is basically 0.55. Now again, if you find out the resultant of these two compounds, 0.55m and this 0.55m, so resultant of this two is going to be in this direction, and as well as if you find out the resultant of this two, so we will get the magnitude is equal to 1.5 into 5. But previously, resultant compound was in this direction, and after 30 degree, it moves at 30 degree. And again, if you consider angle is equal to 60 degree, and again, if you put omega t is equal to 60 in 3 value, based on that, if you derive the phi r, so that will be root 3 by 2 phi m. If you derive phi y, so that will be minus root 3 by 2, and at that time, value of phi b is going to be 0. Now, if you find out the resultant of this compound and this compound, this red and yellow, so that will provide a resultant over here, and it is having value 1.5 into 5. So basically, in all cases, at all angle, we are getting the same magnitude, and with this angle, this resultant vector is also rotating. As if we consider a fourth angle, omega t is equal to 90. And again, in same way, you find out the resultant. So in this case, we are getting the resultant at this angle. So basically, when we had considered our first case, that was over here at this negative axis. And when we had considered this omega t is equal to 90, we are getting this resultant vector in this direction. So basically, again, that is it have same magnitude. So based on this, we can say that when this time is changing, when angle is changing, so while magnitude of the resultant is always constant, but it is changing its direction with time or angle. That's why when this resultant flux will be produced in motor, so it will have always constant value, and that value is defined by this value 1.5 into 5m, but it will change its direction continuously with time or angle. So basically here we are getting the rotating flux. So resultant of this free flux is nothing but a rotating magnetic field. So that's why this theory is titled as a rotating magnetic field. That means when we provide three-phase supply to three-phase stator of the three-phase induction motor, which is having three windings at 120-degree angle. So in that condition, we are getting resultant flux having constant magnitude, but rotating with reference to angle or time. And that's why this theory is known as a rotating magnetic field. So thank you for watching this video.